Hey, everybody. Welcome to histograms. This is from section 2.2. And histograms are basically going to be pictures of data. For example, one of our key concepts, while a frequency distribution is a useful tool for summarizing data and investigating the distribution of data, an even better tool is a histogram, which is a graph that is easier to interpret than a table of numbers. For example, let's say I have this table right here. This is for a McDonald's lunch drive-through service. The times are over here, and the frequency, which means how many people who came through the drive-in line actually took this amount of time. For example, between 75 and 124 seconds, 11 people came into the drive-through line and left. And so on, between 125 and 174, 24 people, and we can continue down. Histogram is this graph on the right, which is a picture, which in my opinion is even easier to see. Now notice on the left, we don't have a lot of different data points. I can read through all the numbers and see which one occurs the most. But over here, I have a graph, which is a picture of everything, and I can see that this right here, which represents, and they're using 124.5 to 174.5 because they're rounding up and down. So that's why those numbers are the way they are. But I can see that this right here has the most people that have gone through. Between 124.5 and 174.5, I can see that almost 25, but 24 people went through the line. And that's what we're going to be working on today. A histogram is a graph that consists of bars of equal width drawn adjacent to each other. That means they're right next to each other, just like we saw here. These are bars right next to each other. The only way they wouldn't be exactly next to each other if there was a gap. Why would there be a gap? Let's say between 225 and 274 seconds, nobody took that amount of time and there'd be a zero. It would look like a gap here in our histogram. The horizontal scale represents the classes of quantitative data value. What does that mean? It means what exactly I'm trying to represent, what I need to know about. And the vertical scale is going to represent the frequencies or how many of those there are. And the heights of the bars are going to correspond to the frequency values. Important uses of histogram is visually I can display the shape of the distribution of the data. And we'll learn more about what the shapes mean. I can show the location of the center of the data. I can show the spread of the data, how it's spread out, and any outliers. Outliers are, say, everybody who goes through the McDonald's line takes between 75 and 324 seconds. And then we find there's somebody who took 2,000 seconds. Well, that would be an outlier. That's not normal. That would not be something that would normally happen, but we can find it using a histogram. Relative frequency distribution, it has the same shape and horizontal scale as a histogram, but the vertical scale is marked with relative frequencies instead of actual frequencies. What would a relative frequency be? I would add up all the people that went through. I have 11 plus 24 plus 10 plus 3 plus 2, which would give me 50. We're looking at 50 people who went through this line. And if I want to find the relative frequency, I would divide each one of these numbers by 50. And that way I could also see how it applies if I had 100 or 200, because they would increase proportionately, hopefully. Again, we have critical thinking, interpreting histograms. We want to explore the data by analyzing the histogram to see what can be learned about this CV dot. Again, we're saying the center, how it varies, the shape, if there are any outliers, and the time it takes. We have a lot of different things we can find out from histograms. If we want to look at different shapes, I can see this right here is called a bell-shaped, and we call it a normal distribution. The one over here in red is called uniform because you can see they're basically all the same height. They may differ by a little bit, but they're all the same height, which means the frequency is mostly the same. In this bottom left, we can see that this is skewed. It's not exactly in the center. It almost looks like a bell curve, but not exactly. And we call this skewed to the right. And the opposite here on the brown, this would be skewed to the left. Normal distribution, always we want to see something that we can make look almost like a bell. Because the histogram is roughly bell-shaped, we can say that the data has a normal distribution. And then if it's not symmetric, we can say it's skewed either to the left or to the right, just like we just saw. Data that's skewed to the left, we call this negative skewed because it has a longer left tail. And if we look at the next one, we call this positive skewed because the right side has a longer tail. A few more pictures. If we want to detect the skewness by comparing the mean and the median, here we can see if something is skewed to the right, there's more data to the right. This is skewed right. We also call this positive, skewed positive. Well, let's talk about what the mean and the median actually mean, because we have two words here that I haven't really talked about. The mean is really the same as what you would call the average. If we want to find the mean, we add up all the values that we have and divide by the total number of values. The median is the exact center number. For example, if I had three numbers, 1, 5, 7, 5 would be the median. Even if it's not the average, it's still the median. It's the middle number. Here, we can see that the median is going to be less than the mean. If the middle number is smaller than the average, then we're going to have values that are going to be skewed to the right. This is a normal distribution. We can see that it's a bell-shaped curve, and it's not skewed either way, which means the mean has to equal the median. The mean equals the median. And if the data is skewed to the left, then we can say that the mean is less than the median. If we have that information, we could basically also say whether things are skewed one way or the other.